There are many process performance metrics. Organizations choose to use the ones that best suit them. There is no real guideline or recommendation. Some useful points to consider. Use performance metrics sparingly. Choose wisely and in a manner that maximizes your ability to describe the performance of the process and the organization. Make sure everyone in the organization understands the performance metric and how they influence the metric. Make the metric very visual. Review and discuss with the workforce regularly. Defect tracking is a common way to measure performance. Here are some common defect performance metrics. Total opportunities is the product of the opportunities for the defect and units. Defect per unit is a ratio of defects to the number of units. Defects per normalized unit is the negative natural logarithm of the nth root of the roll throughput yield. Note that n is the number of steps in the process. Defects per unit opportunity is the ratio of defects per unit over the number of opportunities for the defect. And finally, defects per million opportunities is a very common measure in Six Sigma circles. It is the defects per unit opportunity times 1 million. Instead of looking in terms of defects, we could also understand the process in terms of yield. The Poisson equation is normally used to model defect occurrences. However, if we set x equal to 0, what is known as defect-free, we obtain a calculation for first pass yield. Normalized yield was introduced in the previous slide. As a recap, it is the nth root of the roll throughput yield. Note that n is the number of steps in the process. We will discuss roll throughput yield in greater detail on the next slide. Total defects per unit is the negative logarithm of the roll throughput yield. Roll throughput yield is defined as the product of yield rates through multiple process steps. The determination of roll throughput yield can help the organization localize the weak link in the process. Roll throughput yield can be of paramount importance when dealing with processes in series. For example, the roll throughput yield of the process illustrated is the products of the yields, or 0.415. A 41.5% roll throughput yield is extremely low, but not a surprise when you consider that these processes are all in series, and process 3 appears to be in the most difficulty. In fact, we could argue that process 1 and process 2 are not optimum. Process performance can be very dicey in series systems. Even though there is more cost involved, parallel systems are considered a standard feature in manufacturing and process design. Some steps to follow when finding roll throughput yield. First, calculate the yield for each step and then the resulting roll throughput yield. Second, the roll throughput yield for a process will be the baseline metric. Finally, look for opportunities to shore up performance in processes with low yields.